Chapter 9, Matrix and Determinants. Part B, Determinants. In Chapter 10, we have already discussed how to find the determinant of 2x2 matrix and 3x3 matrix by the basic expansions. And then remember, if we have 1x1 matrix, that means if we have one and only one element, the determinant of matrix, is equal to A. At this part, I want to introduce another way to find the determinant and how to simplify it. Turn to page 10, part B. I want to use example 9.12 to illustrate how to use another way to find the determinant of matrix. First of all, I want to introduce some terms. We have already discussed it, but I haven't told you some of the terms. For example, do you remember if you want to find the inverse of a matrix, you need to find this 2 row and column. You need to find the values of this part. And we will call this part is the minor matrix of 1, 1, because you hide row 1 and first row and first column, and this is the minor matrix of A11. For example, this one, if you hide this row, the first row and the second column, 2, 0, 2, 8, 0, and 4. This is the minus matrix of 1, 2, because you hide row 1 and row and then how about this element, including the sign? We'll call this as the cofactor. So how to find the determinant of this matrix? Maybe you can choose one of the row. If I were you, I would choose row 3 because I can find row 3 we have 1, 0. But I want to demonstrate the basic idea. I use row 1 and I will repeat it by using the first row. The first row. The first row, first element is 1. That means the cofactor is 1. 1 times the minor matrix of 1, 1. So you find this row and this column. This is 2, 8, 0, 4. Plus the cofactor times the minor matrix. What is the variable cofactor? Do you remember what is the values of the cofactor of this term? Is not only 4. And do you remember this is positive, negative, positive, negative, positive, negative, positive, negative, positive. So this is negative 4. Times the minor matrix. So it's 2, 8, 0, 4. And then plus the cofactor. The sign of the cofactor is positive, so write down 7. And then the cofactor at the minor matrix is 2, negative 3, and 0, 1. And so this is 1 times 8 minus 4 times 8. Sorry. The first this is negative 3 and this is 1. So this is not 8. This is negative 12 minus 8 is negative 20. So negative 20 and minus 4 times 8 and then plus 7 times 2. Negative 20 minus 32 plus 14. Negative 38. I want to repeat this idea by using the last row. The last row, the first one is 0, so maybe you can ignore it. That means 0 times the minor matrix behind this 2 row, so it's 4, -3, and 7, 8. And then minus 1 times 1, 7, 2, 8. And then plus 4 times 1, 4, 2, -3. So the first one is 0, you can ignore it, and then this is -8 minus 14. So minus 8 minus 14 times -1, and then plus 4 times -3 minus 8. So you can see the answer is equal to -3a. They're equal. So why I need to choose this row? Because I find one of the element is equal to 0. Then you can make good use of this row. This is another way to find the determinant. For exercise 8, 9, maybe you can do it by yourself. There are several properties of the determinant. You need to remember, because sometimes you need to know how to simplify it. For example, what is the meaning about what is the first property? This is A1, B1, C1, A2, B2, C2. And then you can see, if we take transpose, that means all the row we change to column. All the row you can change to column. And then these two matrix and the determinant are equal. How about the second? What is the difference between these two? You can see we interchange two row. This is A1, B1, C1, and A2, B2, C2. I change to B1, A1, B1, C1, and A2. If you interchange two row, you need to take negative sign for the determinant. If you find one of the row are equal, all the element is equal to 0, the determinant is equal to 0. Not very difficult to prove, because you can make good use of this row by using the cofactor, and then all the cofactor is equal to 0, and times the minor matrix is also equal to 0. If two rows are equal, A1, B1, C1, and this is also A2, B2, C2. This is equal to A2, B2, C2. If two rows are equal, the determinant is equal to 0. And then this three property I want to elaborate in our lesson, because I want to use some time to discuss with you. And make good use of this three property. We can also simplify or find the determinant. For example, 9.13. This is the last example related to the determinant I want to discuss with you. How can we find the determinant of this part? Show that the determinant equal these two parts. And maybe you can use the expansion and expand the left-hand side and right-hand side, and then you can also prove it. But this is not the right way or the best method to find the determinant of this matrix. I suggest we can use the row operation, the elementary operations of the matrix. That means the property of the matrix. We have discussed it before, and then to find the determinant. How? For example, I know if we use row 2 minus row 1, and then we have new row 2. By using this elementary row operations, we will not affect the values of the determinant, so that I know the new row 2, that means we can use this row minus this row, we have new row 2. So this is equal to 0. And then this one is b minus a, and then b squared minus a squared. The first row is unchanged. And then we can also use row 3 minus row 1. We have new row 3. We can make this term becomes 0. 0 minus a and 0 and c squared, and c minus a and c squared minus a squared. And you, by applying the elementary operation, you can find, I can change the first column, become 1, 0, 0. According to the expansion by the cofactor, I know the determinant is equal to, this part is equal to 1 times the submatrix, the minor matrix, B minus A, B squared minus A squared, and C minus A, C squared minus A squared. And then plus 0 times the minor matrix. And this part, maybe next time you can ignore it, okay? You do not need to write it down. And then according to the second property, and now what I have done is that I change 3 by 3 matrix by using the elementary operations. That means the property of the matrix. And then I can change to 2 by 2 matrix. I can also observe this is B minus A and this is B squared minus A squared. Can you see? We can have some common factor. I can take it out. B minus A and then B plus A. This is C minus A times C plus A. For the first row, I can take out B minus A. Remain 1 and B plus A. For the second row, I can take out C minus A and then remain 1 and C plus A. Now I can find the determinant by expand it directly. C plus A minus B minus A. So the final answer is B minus A times C minus A times C plus A minus B minus A. So this is what we want. This is our left-hand side. Done. Finish. So why I want to emphasize the application of the property of the determinant of a matrix and make good use of it. Sometimes we can simplify or find the values of the matrix, find the values of the determinant of a matrix.